Welcome you all to the course on signals and system. Myself Mr. K. Arun Kumar. This lecture is about unit 3 in signals and system, that is continuous time system analysis. Previously we have completed 2 units. In the first unit we discussed about signals and system properties and how to find the various systems and various signals. In the unit 2 we have completed the analysis of continuous time signal using Fourier series and using Fourier transform. Fourier series method is applicable when your x of t is periodic in nature. Fourier transform is applicable when x of t is aperiodic in nature. Now we are going to start unit 3, continuous time system analysis. Under that, the first topic is Laplace transform. Pierre Simon Laplace is a great mathematician. He developed mathematics in astronomy, physics and statistics. Actually, he started to work in the calculus, which leads to find the Laplace transforms. And finally, he focused on the celestial mechanics. Actually, he is one of the great scientists. He suggests the existence of black hole. The picture shows is the great mathematician Laplace. By the definition of Laplace, the Laplace transform is defined as it will convert f of t into f of s, which means that continuous time domain will be converted into frequency domain. So, as per the definition, formula for x of t is nothing but Laplace transform of x of t is equal to x of s, which is nothing but integral over minus infinite to plus infinite x of t into e to the power of minus s into t into dt, where s represents Laplace notation, which is nothing but sigma plus j omega or sigma plus I omega, where sigma is the real number, omega is the imaginary number. Whenever s is purely imaginary, that is whenever s is equal to j omega or I omega, then your Laplace transform will becomes Fourier transform. Whenever s is a complex number, then it remains same, that act as a Laplace transform. So simply I can say that, or I can relate that Laplace transform is equal to Fourier transform plus region of convergence. A Fourier transform fails to express or fail to suggest about where the function will exist. That concept has been added by the Laplace along with Fourier transform. Okay, so simply I can say a mathematical expression, that is Laplace transform is equal to Fourier transform plus region of convergence. So where I can use this Laplace transforms? Okay, here I listed few topics. Okay, the first one is to do the analysis of stability analysis of continuous time system, and to solve diffusion equations, to solve wave equations, and in semiconductor mobility, and in call completion in wireless networks, vehicle vibrations on compressed rails, and to study the behavior of magnetic and electric fields above the atmosphere. These are all the very few applications I have listed here. There are n number of applications of Laplace transform. Okay, and finally I will end up with this. Okay, so better you can look into these 3 practice questions. The first one is just go through the history behind the Fourier transform and history behind the Laplace transforms, how they invented these 2 transforms, and what are the major related terms between this Fourier and Laplace. Okay, so Laplace is the master for Fourier. Okay, Fourier is a student of Laplace. Just go through all the history behind this, so that you will get some more interest towards this transforms. Okay, and the second one is in all the transforms, whether it is a Fourier or Laplace, the e power minus j omega t is always multiplied with x of t to get frequency domain representation. What is the importance of e power minus j omega t to get frequency domain? If e power minus j omega t is not present along with x of t, then what will be the equation, whether that type of equation is allowed or possible, that we have to check. And third practice question is, find the transforms, that is both Fourier transform as well as Laplace transform for unit step signal and compare the result. Okay, thank you. With this I will close.